All right, so today's lesson adds some more angles to the mix here. The other day, you guys dealt with inscribed angles, right? So when you had a circle and the vertex was on the circle, right? You guys said the inscribed angle, right, was equal to half the measure of the arc, okay? So now, right, we have the inscribed angle, right? So you have the inscribed angle, but then you also had your central angle, and that was when the vertex was at the center. We said that was equal to the measure of the arc. Now, what happens if I look here, you could say that these two lines are secants, right? Or you could even have chords here that intersect. But when you look at the vertex of this new angle, what you'll see is that vertex is inside the circle. It's not at the center and it's not on, it's inside. And when we talk about an inside angle, it's an angle whose vertex is inside the circle. Okay? Now, what happens is when you have this inside angle, what happens is it actually intercepts two arcs. Okay? So when I look at these two arcs, it intercepts, right? What we say is the inside angle is equal to the sum of the two arcs it eats. So it would be x plus y all divided by 2. Okay, so it's basically the average of the two arcs. So when we look at the two examples here, when I'm looking for this angle, if I trace these lines down, that angle eats this arc and it eats this arc. So all we're going to do is add the arcs, divide by 2, and 136 divided by 2 would be 78 degrees. Okay? Now, here's the thing. When you look at the next example, you're looking for the measure of this arc. And you have to recognize that you have the inside angle and you have to measure this other arc. Well, again, if I look at this, right, the inside angle is equal to arc plus arc divided by 2. So if I fill this out and I say, okay, the inside angle is 94 degrees equals one arc is x, the other arc is 112. When I add those together and divide by 2, that would give me the measure of the inside angle. Well, now I can basically solve this equation for the other arc. So first thing I do, multiply both sides by 2 to get rid of the fraction. So I'm left with here, x plus 112 equals 2 times 94 gives you 188. And now, when I subtract 112, x is equal to 76 degrees. Okay? So that's an inside angle. So now we go to an outside angle. An outside angle is basically an angle whose vertex is outside the circle. So if you look at the three angles here, this angle 1, this angle 1, this angle 1, all of those angles are outside. Now, if you look here, right, different segments and lines make up these angles. So when I look at this, that outside angle is made up of, is made up of tangent lines, aren't they? Tangent, tangent. If I look, this outside angle is made up of secant and secant. This one's made up of a tangent line and a secant. Well, here's the thing. When we go to find the measure of the outside angle, what we basically do is we take the far arc, which is the bigger arc. We subtract the near arc, which is the smaller arc, and we divide by 2. Okay, so instead of adding and divide by 2, we are going to subtract and divide by 2. So when I look at the first example here, right, I have an outside angle x. So x is equal to my far arc. This is my far arc. So if I look at this, right, these two tangent lines eat this arc. That's my far arc, so 268, minus my near arc, which is 92 degrees. So I'm going to subtract those and divide by 2. That gives me 176 divided by 2, which means that outside angle would be 88 degrees. All right. So now the next one, this outside angle eats this far arc and it eats this near arc. So when I look at the outside angle y, that's going to be the far 110 minus the near 30. Subtract them, divide by 2. And that would give me 80 divided by 2, which is 40 degrees. Okay. Now the next example, when you look here, you have this far arc, right? And then you have this near arc. So this outside angle T is equal to the far 195 minus the near divided by 2. So 195 minus 77 gives you 118. And 118 divided by 2 will give you 59 degrees. Okay? Now these next few examples, right? When I look now, I'm looking for this arc. So what you have to remember is I still have my far arc, my near arc, and my outside angle. So when I write out that formula, your outside angle equals far minus the near, all divided by 2, you're not going to change anything here. So my far, 95 degrees, minus my near, which is at z, all divided by 2, is equal to 20. So now all I have to do is solve this equation for z. First thing I'm going to do, multiply by 2. So 95 minus z equals 40. I'm going to subtract that 95. That's going to give me negative z equals negative 55. And when I divide by negative 1, z is equal to 55 degrees. Okay, now example 7 here. If I look at my far arc here, then I look at my near arc here. Right away, there's two things that you need to understand. One, there's an easy way to do this because what do the green and the blue arc have to add up to? So basically, the easiest way to do this would just be 360 minus 110, which would be 250 degrees. But if you wanted to do far minus the near, all divided by 2, equals that outside angle, I could easily get the same answer here. Okay, add 110, and W is equal to 250 degrees. Either way you do that, you get the same answer. Okay, so the last example here, I'm going to tell you right now, the first thing you want to do is take the given information and mark the diagram. So OB is 98, so that's 98 degrees. OY is 28 degrees. Then YD is 62 degrees. AD is 38 degrees. Now, I'm missing right now the measure of arc BA, right? That's right, that's me. Okay, easiest way to find arc BA is just do 360 minus all the arcs I know. So, when I do 360 minus the 98 degrees minus the 28 minus 62 minus 38, that would give me 134 degrees. Now when I go to find the angles, right? Here's the important part. When I look at angle 1, I have to know angle 1 is an inscribed angle. So when I highlight the lines that make it up, so that line and that line make up angle 1, and if you notice, it eats this arc. Well, what is the measure of that yellow arc? Well, I have to add 134 and 38. That gives me 172. So angle 1 is 172 divided by 2, which gives me 86 degrees. Okay? Now, angle 2. When I look at that, that's an inside angle. And if I draw the lines that make up that, you get these two arcs eaten. And remember, to find the measure of an inside angle, we're basically going ahead and adding the arcs, so 28 plus 38, and we divide by 2. So 28 plus 38 gives you 66 divided by 2 means that angle, right, is 33 degrees. Now, I am going to erase these lines to help you with the last one here. Okay, when I go to find angle 3 now, okay, so remember this was 28 degrees. Angle 3 is an outside angle. And if I highlight the lines that make up angle 3, I'll notice angle 3 eats this arc and it eats this arc. And an outside angle is basically the far arc, which in this case is 134, minus your near arc, which is 28, subtract, divide by 2. That gives you 106 divided by 2, which is 53 degrees. Okay? So guys, with this, I know some of you don't have printers, but do yourself a favor. Draw the diagram out. Get a pop can to draw nice circles and use straight edges to draw the lines and mark the diagrams. Please let me know if you have any questions.